So welcome everybody to already the ninth lunch webinar in the series. We kind of in the middle. We have in total about 14 of them. We go through different components related to analyzing changing impact of compounding and multi-hazard events. And one important aspect of that is also to characterize and describe past events. And this we do among different methods also with impact chains. And today we will look at that aspect of impact chains. And Silvia, Cocuccioni, and Max Pittore, who would join a bit later from EURAC, they would present it. The concept of impact chains, maybe also give some examples and some tools that you could use for developing impact chains. It's also a tool that we might also use when we have the summer school later on in July. We are busy with these impact chains within PARATUS, also within the 4 case study areas. So I would like to invite Silvia to start your presentation.
Yeah, hello and welcome also on my side. Thank you, Case, for the introduction. So I will start by sharing the screen. 1 second. Okay. I think it's not yet in presentation mode.
No.
Okay.
Yeah.
Now it should be, right? Yeah.
Yes, now it's good.
Okay. Yeah. So as Case was introducing, today's lecture is about the impact chains. So during this talk, we will first introduce EURAC as a research institution, what we do, but very briefly, just to give you a little bit of context and who we are, myself and Max. And then we will give a brief introduction also on the risk concept. We know that it was already addressed in the previous lecture, so we try to keep it brief, but just also to put the impact chains more in this case, it will be more on the climate change adaptation context, since they were developed initially within this community. And we will explain what the impact chains are, how to develop them, and also in which context they can be used, giving also some examples from previous projects, and also some tools or some softwares to develop or to visualize them. This will be done by Max later, and then also we will try, but let's see if we have time and if we can manage a little practical exercise developing a small impact chain. Let's see if this will work. So first of all, EURAC research. So EURAC is a private research center that is located in the northeast of Italy, so in the Alps, as you can see in the map here. In particular, it's composed of many different institutes working on many different topics that you can see here. So from the mummy studies, so working on, for example, this mummy called Ötzi that was found in the Alps, to very different topics, so renewable energy and climate neutrality. So it's more on the mitigation side of climate change. And we have biomedicine, by applied linguistics, so a very broad, let's say, range of competences and disciplines included, and some centers which are instead more transdisciplinary. So for example, advanced studies, Center for Sensing Solution, that they put together more expertise from the different institutes. In particular, myself and Max, we work for the Center for Climate Change and Transformation, which includes expertise, as you can see here with the rectangles, with the boxes, expertise from many different centers and institutes, as climate change is a really broad topic and needs expertise from many different disciplines. In particular, we are part, and Max actually is responsible for the Climate and Disaster Risk Group, where we have 4 research lines: climate services, natural hazards, risk assessment, and risk governance. So ranging really from the more hard or natural sciences, so including natural services and natural hazard modeling, to risk assessment and risk governance, which, let's say, encompass also more social sciences as well. So let's say our mission is, first of all, to understand and to model the impacts and risks connected to natural hazards, not only under the current conditions, but also under future conditions. So, for example, including climate change. And we are also doing this using a multidisciplinary and integrated approach. And one of these, the main, let's say, tool or approach that we use is the impact chains. That's why we are here today. Then one of other main activities is to develop customized climate services, especially for the mountain environment, being located in the Alps, but not only. We also work for other national contexts within and outside Europe. And this activity is also carried out to support the risk analysis activities. And finally, as I was saying before, the more, let's say, social sciences oriented activities involving risk governance and risk management, supporting also the local institutions in this field. So a little bit more in the interface between the research, policies, and praxis. So as you can see, some activities are more related to European projects, for example, Horizon Europe, such as PARATUS, but also other more local projects, for example, Interreg Alpine Space. So we really focus, we try to have South Tyrol, that's where we are in Bolzano, as our lab, but also to use more European experiences to broaden and to expand our work. So some EU projects, and on the other hand, also more consultancy style projects. For example, we work at climate change adaptation strategies and plans, for example, for the province of Bolzano, where we're located, but also for other regions within Italy, such as Regione Marche, that is a little bit more in the south, or even for the entire Germany. And within these projects, we use the impact chains. Let's say we don't only try to develop the tool from a research side, from a research perspective, but we also apply it within more consultancy style projects. So today here at the moment it's only me, but then also Massimiliano will join. So I am Silvia Cocuccioni, as Case was introducing, and I'm a researcher. I've been a researcher here in the group for the past 4 years, more or less. And I'm an environmental scientist by background. So I have a bachelor in environmental sciences, so it's more focusing on natural sciences from the La Sapienza University in Rome, and then I moved to the Netherlands, to Wageningen, where I studied more environmental management. So I'm a little bit in between the social and the natural sciences. So I work mainly on the science policies interface, so focusing on risk assessment, mainly through participatory approaches. That's why the impact chains are, let's say, at the heart of my job for some of the projects I mentioned before. So both the European ones, but also the more, let's say, consultancy-oriented ones. As I was saying, we will give a brief introduction on what we mean by risk. Again, I know this was repeated in the previous lectures, but we'll do it through the lens of the IPCC our assessment report 5 and 6, as this was really the basis through which the impact chains, the lens, let's say, through which the impact chains are built on. So how do we define risk within this context? We define it as the potential for adverse consequences for human or ecological systems, and also, very importantly, recognizing the diversity of values and objectives that are associated with such systems. So we can try to have a look at these words that are in bold. So as risk is really a complex concept, it encompasses really many different factors or components, and it really requires knowledge from different disciplines and also a lot of data in order to assess it. So the word potential really makes clear that the uncertainty behind its assessment, and also that sometimes there might be incomplete knowledge. So this, like potential, so uncertainty and incomplete knowledge are really a key element in the concept of risk. And also in the IPCC use, risk really refers only to the negative, or as you can see here, adverse consequences. So let's say the potential for positive outcomes, so should really be described using other terms such as opportunity or potential benefit. So we only look, let's say, at the more negative side within this context here. And also, when we say risk, so the concept of risk should not be used to describe the outcomes only related to the physical system. So for example, if we say flood risk, should not be used to describe the frequency or the intensity of the flood events itself, but it needs to be linked to the consequences, in case that adverse consequences of such events for the human or for the ecological systems. And regarding the last, so recognizing the diversity of values and objectives, this really like underlines or emphasizes that different individuals, so maybe different stakeholders or actors, will evaluate the consequence of such risk in a different way. So what can be seen as a risk for one stakeholder might not be perceived the same by another one. So because they have different values, objectives or goals. So for example, if we have the risk of damage to the transport sector due to flooding, the road owner or people actually using the road or people transporting goods specific on the roads, they might really address risk in a different way. So what is the risk for one can be different from the other. Also in the IPCC, but also as you saw in the previous lectures, risk results from the dynamic interaction between hazards, exposure, and vulnerability. So this concept really require different disciplines. So the more, let's say, natural sciences oriented with hazard modeling, but also more social sciences and land use planning or socioeconomic knowledge about the context in order to analyze and explore the exposure and vulnerability components. Now we go through the different components. I do it quite quickly as this has been addressed already. So since we are in, let's say, in a more climate-related context, let's say we divide the hazard according to the IPCC. A hazard can be divided between slow onset processes or more extreme events. And in the PARATUS project, we don't only look at climate-related hazards, but also at other type of hazards, such as geological or technological, for example. And as I was saying, we have rapid onset or extreme events, as such can be like a heat wave or a snowstorm, or slower events that, for example, the slow decrease of glacier cover or snow cover, or the increasing aridity that happens through time, or sea level rise, which might not be, let's say, relevant here in the Alps, but for many other contexts it is. Then another important component of risk is the exposure, which describes who or what is exposed. So this is not really only the assets, but also the functions of systems. So for example, in case of the transport sector, it's not only the road itself, so the physical asset, but also the function, the transport function that can be interrupted in case of the occurrence of a hazard. And then finally, the vulnerability, that is the propensity or the predisposition to be adversely affected. And this itself really encompasses really many different subcomponents, such as sensitivity or susceptibility to harm, lack of capacity to cope and adapt. Within different communities, there are different definitions, or this includes or does not include some of these concepts. We are aware of that. This is just, let's say, the background within which the impact chains were developed in the first place. And while, let's say, the hazard assessment can be more straightforward from certain point of view, the vulnerability data also about vulnerability can be more challenging to collect, as this really encompasses many different fields or topics, ranging from environmental, but also physical, technical, socioeconomic, institutional, policy-related. So we brought a broad range of topics. And all of this together can create or lead to cascading potential impacts, which can then lead to a potential for adverse consequences that we define as risk. But then there can be also other underlying risk drivers, such as poverty or social injustice, demographic development, land degradation, or conflicts, such as, for example, the war in Ukraine, that are really aggravating the exposure or the vulnerability factors, and can be really as important as climate change, for example, here in the climate change context. So, as you can see here from this graph, it really encompasses a lot of different components and requires the knowledge from different disciplines. So the impact chains in this context are really an analytical concept that really tries to map or to understand, systemize, and prioritize all the different factors. So the different boxes we saw before that drive the risk, so that lead to the risk. So in other words, there are conceptual models that are based on cause-effect chains and include all the major factors and processes that we saw before that lead to the specific climate risk in a specific context. So for example, it can be regional, sectoral, local. And as I was saying before, it's really originating, or it was born within a climate change adaptation community. So risk assessment within that context. But now in the last years or months, there have been new developments or application. For example, in the PARATUS project, we are also trying to apply the impact chains for past events and more for, let's say, more disaster risk reduction context itself, without not necessarily including the climate change adaptation. In this slide here, you can see some sources where you can read more about impact chains. From left to right, they're a little bit in a chronological order. So first of all, our, let's say, Bible of the impact chains is the Vulnerability Sourcebook, which, let's say, makes use of the knowledge of the IPCC Assessment Report 4. So you will find there a different use of terms. So if you are planning to read it, you should consider also reading the risk supplement, which instead updates the Vulnerability Sourcebook with all the terms from the IPCC Assessment Report 5. So, and these are the terms that I presented before. So let's say one updates the others. And finally, a more recent publication, that is the UNDRR one here on the right. And there it puts the impact chains in a broader context of comprehensive risk assessment. And I think that's the one we recommend reading more, as it's more it uses the impact chains in a more updated way. So how we intend them nowadays, also for within EURAC, or how we are also planning to apply them for PARATUS. And also here, same year, you can also find this publication, which is more synthetic, in case you don't want to read the hundreds of pages of the UNDRR publication. I will give you an example of an impact chain, just to put the presentation a little bit more in practice. So if we start from the risk, for example, if we want to map or understand all the different components which lead to the risk of damage to poverty and loss of lives due to flooding, first of all, we have to understand which hazards may contribute to this risk. And for example, of course, this is a very simple example. They can be the increase of heavy precipitation, which might lead to the increase of flood events, which might lead to the increase of damages due to the flood event. As you can see, the damages, for example, can affect as an exposure element property and buildings. Or it can also lead to the increase of homeless and injured people. And in this case, it affects the population living in these flood-prone areas. And there are many different factors which might, let's say, make the system more vulnerable. For example, related to the increase of flood events, the reduced natural retention capacity or the reduced erosion protection can, let's say, increase the likelihood, or can increase the vulnerability of the system, and so make it, the increase of flood events can be, let's say, more likely somehow. And other factors such as wetland degradation or deforestation can even make the system even more vulnerable. So in this box, you can see the vulnerability factors. So these are not only the susceptibility and sensitivity factors, but also the capacity to cope and adapt. So as I was saying before, it's many different factors. Some are more like nature related and others are more institutional related, such as this last one. So the insufficient protection measures for flooding, or which might be due to the lack of urban planning. As an underlining risk driver, we have, for example, the population increase, which is not maybe it's a factor, let's say, coming from which characterizes the system as a whole. So this is just a brief example of an impact chain that we will show you again to add other factors or to explain you further processes regarding the impact chains later on in the slides. Okay, 1 second. Is it still in the presentation? Okay. Okay, so impact chains can be built through participatory processes. That's also how we are doing it within the PARATUS project. So together with stakeholders and experts, for example, in a workshop setting, so that together we can really create a commonly agreed picture of all the root causes. But it can also be expanded to desk-based research. So after collecting the information from the stakeholders, or even before, it's possible to reports or to looking at data to really expand this knowledge and insert new boxes, new components, new arrows, and so on. And in this, you can see here, for example, 2 impact chains developed through participatory process in different contexts. So here it's even in Japanese and in Italian. So as I was saying, we try to apply them or develop them in many different international and local projects. Here are other examples. So so the impact chains were originally developed within the climate change adaptation context. So they can first be built to describe the current situation, but they can also be extended to describe the potential future situation. And in order to do that, it needs to be taken into consideration also the projected future climate, but also the potential future trends in exposures, for example, in case of if there is like a strong urbanization going on in the study area, this might lead to higher exposure, or also future trends in vulnerability. For example, if there is an aging trend in the population. And also they can be helpful to really identify the adaptation options. So looking at the different vulnerability factors, but even the exposure factors, it's possible to really pinpoint where it's possible to act in order in the climate change concept to adapt to climate change, or in the disaster risk reduction to really find risk mitigation measures. For example, in this case, since one of the causes or one of the vulnerability factors identified was wetland degradation, for example, wetland restoration as an adaptation measure could help. And the same as reforestation or capacity building in order to improve the urban planning. Or if you want to act on the exposure instead, so reducing the people living in the flood-prone areas, for example, relocation could be one adaptation measure. So as we were saying, they can be helpful to identify adaptation options, but they can also serve as a backbone, so as a sort of skeleton to integrate various methods. So also the different boxes or components can be modeled in a quantitative way, or also they can be integrated with an indicator-based assessment or approach, or with further participatory data collection. In case, like in this slide, you can see some more information regarding the indicator-based type of assessment, which can be built up on the impact chain approach. So all the different impact chain factors, so all the different boxes you saw before, can be, for example, described by some proxy indicators, and they can be normalized and also aggregated to composite indicators and mapped in a especially explicit way. And this is useful especially when you have to compare different areas, for example, different municipalities or different regions, as if you maybe have to describe only one area without comparison, maybe a qualitative approach can be better, as all the different nuances and different details can be described in text, and even when quantitative data is not available. So the different components, hazard, exposure, vulnerability, there can be a composite indicator for each of them, and it can be mapped even to really have a risk map using the indicators coming from the impact chain. To give you some example, even also this very simple of indicators for the previous impact chain you saw. For example, in the case of the hazard, there can be the number of days with precipitation higher than 100 millimeters, or for in case of the exposure, the number of buildings per square kilometer in flood-prone areas, with people similarly, or the percentage of wetland area as an indicator to describe wetland degradation. So, for example, if this has decreased in the last years, and similarly also with the forest area protected or the area covered by natural forest. Or in case of more institutional capacities, it can be the number or the percentage of municipalities with a certain planning process going on. Okay, I will give you now an example about this type of approach, so indicator-based assessment that we carried out using, starting from, let's say, the impact chains, and it was carried out in the EURAC Alpine Space ADO, so Alpine Drought Observatory. And you can also find here a publication that describes the whole work. So in this project, we started from the impact chains, as you can see here in gray. So this was more to define the context, also using a participatory approach. So asking the different experts and partners of the project to develop different impact chains, in particular for 2 case studies, Podravska in Slovenia and Turkau in Switzerland. And in this, we had some preliminary impact chains, but then we decided to really focus more on the vulnerability aspect. So we started with a really preliminary impact chain, and then we conducted some semi-structured interviews to refine the impact chains, only focusing on the vulnerability component. Okay. So here you can see, I don't know if you actually can see it, it's really small, a list of all the vulnerability factors that the expert mentioned in the same structure interviews. So this factor that might increase or decrease the vulnerability. And I forgot to say that it was in the specific for the agricultural sector to drought, because as the name of the project at Alpine Drought Observatory, the focus was only on drought. And in this case, we decided to focus on the agricultural sector. So these were all the different vulnerability factors, for some of which we could find data, as you can see here in gray, but for some others, we could not find data. In particular, we were looking for sub-regional data, as we wanted to map or to analyze the differences between the different municipalities within the region. In particular, the results here are about Podravska only, so one of the 2 case studies we addressed. And as you can see here, we were not able to find data belonging to the same year. So this might not be a problem for some static factors, such as slope, but for others, for example, farm size, it can be a problem, as the average size can maybe vary from one year to another. And also this is one important factor you have to take into account when using the impact chain or we're carrying out a risk assessment in general, that there can be some data constraints. So your analysis needs to be a little bit a compromise between what the stakeholders mentioned in the qualitative part of the assessment, and also what is really available on the quantitative side, so on the data side, in case you want to move the impact chains from the more participatory and qualitative approach to the indicator-based one. And so within this project, then we also try to assign a different weight to the different factors mentioned by the experts. So we try the equal weighting, so giving each factor, each vulnerability factor the same weight, or the expert weighting method, so giving a different weight according to what the expert said during the semi-structured interviews. And as you can see here, 4 different factors were rated higher than the others by the experts. And these are access to local food markets, farm diversification, presence of irrigation infrastructure, and soil texture. So according to the experts, these factors would make the system, so the agricultural system, more or less vulnerable. And we try to map, according to the data and the indicators we found, this for the different municipalities or Lautu regions of the Podravska case study. And the data was then normalized, and then here you can see the overall vulnerability, so putting together all the different vulnerability factors for which we could find sub-regional data. On the left, using the equal weighting, and on the right, using the expert weighting. So when you use an indicator-based assessment, you also have to keep in mind which type of weighting you want to use if you're using knowledge coming from the stakeholders, for example. As you can see, there are the results can differ. So it's one factor that you should take into account. So up to now, so I presented something about more the climate change adaptation context, something more about the indicator-based approach, but impact chains can also be used to describe past events. So to identify or to analyze multi-hazard interactions that you saw in one of the previous lectures, and also to identify different cause-effect chains and impacts that are related to a specific past event. Within PARATUS, we have some what we call learning case studies, which we will analyze through the forensic analysis, which was also presented in one of the past lectures. But forensic analysis can support also the impact chains. I mean, they can mutually support each other. So we will also build some impact chains regarding specific past events that you can see, for example, listed here in this table. And now I will give you one example more related to one specific past event, in this case, Vaia, an event that occurred in the north of Italy in 2018, which, let's say, you will see that started in 2018, and then the consequences and the impacts, the cascading impacts went on even in the subsequent years. So in 2018, due to strong wind and precipitation, really thorough extended windthrow occurred, which led to the increased risk connected to avalanches, for example, due to the absence of trees, so the protective forest could not act anymore. So this eventually led to an increase risk connected to the avalanches, but then also high temperatures occurred already from spring. And eventually, then we also had a bark beetle damage of the trees, leading to even a decreased effect of the protective forest. So here we have really another summary impact chain, so a simple one regarding the Vaia event, where you can see it starts from the hazard that occurred in, let's say, in the autumn 2018, but then led to many cascading impacts. So, for example, if we start from the strong wind, which occurred, this led to the windthrows, so the falling of trees, which caused the damage to the forest roads, so really impacting road infrastructure as an asset or as an exposure element. But the falling of trees eventually also caused some power disruptions, as well as railway disruptions, so really impacting, in this case, the railway infrastructure. and then many different vulnerability factors which might be linked to certain impacts. But so you can see that different impacts can occur at different times. So suddenly after the strong winds, but also later in time. So for example, as you can see here, so here we have a timeline. So the occurrence and the duration of the different factors really need to be taken into account within the impact chains and within the risk assessment in general. So for example, the strong winds can really happen within minutes or hours, within the real beginning of the event. Falling of trees maybe slightly later, and then this might lead to power disruption and telecommunication disruption, maybe even in the following days. But then if we look even at weeks and months later, or years, this can still have a cascading impact, as for example, as I mentioned before, the uncontrolled spread of bark beetles. As you can see here, these yellow trees, which might lead to the increase of wildfire risk, or the increase of landslide or avalanche risk due to the protective forest that is being damaged. And this is occurring even now. So when you carry out, or when you develop an impact chain, you should not only consider the impacts that occur at the moment, but you should set up, let's say, you should define in which time the impact chain is relevant for, and if you're interested, you should also map all the cascading impacts which might occur months, years later. So in this context, so when developing an impact chain, you should really try to identify the context, first of all, and the objectives of the impact chains. So as risk is really value-based and it really depends on the objective, goals, and values of the different stakeholders, you should really take into account which values you want to protect, so which targets you want to achieve, and which might be affected by climate-related hazards or by hazard in general. And also, you should define the scope and the method to develop such an assessment. So you should define if you want to focus on a specific hazard, or if you want to focus on a specific sector, or even the spatial scale. So if you want to really, for example, in the case of the ADO project, look at the different municipalities, or which scale you really want to work at, and also the temporal reference. So in case of the VIA example, if you want to look at the consequences, no, actually that's the temporal scope. So if you want to look at the consequences just within a few hours from the event, or if you want to look at the consequences even later in time. And also how you want to carry out such an assessment. So if you only want to focus on the qualitative side, so build only an impact chain, or if you want it to be data-driven in the sense of an indicator-based approach, like we did in the ADO project, and if it should be bottom-up, participative, like we usually do with the, like we've done both, like in the previous examples. And it should also take into account the existing data. As I was saying, it can be sometimes a constraint, or you need to have compromise between what the stakeholders really insert or mention in the impact chain and what is really available at the quantitative level. Okay, I see that Max is already here, so maybe we can continue with the presentation, and then in case we have time, we can try the practical, let's say, the practical exercise. Should I continue sharing, or you want to share it?
Thank you, Silvia, and good morning, everybody. I think if you want, you can just continue sharing the presentation. I can just ask you from time to time to go on. Mm-hmm. And maybe very briefly introducing myself, I'm Massimiliano Pittore, and a senior researcher and a group leader in EURAC research. I'm a physicist by background, and I've been working with risk and risk-related concepts in the last at least 13 years, starting with seismic risk and then moving increasingly towards a more complex multi-hazard type of risks, and then more recently even to climate-related risks. Now, as Silvia has shown to you so far, the development of impact chains have been progressing steadily over a number of years, and this is something which has been really pioneered here at EURAC Research, let's say thanks to a long-term collaboration with other institutions, especially JZ in Germany, for instance, which are really tasked with implementing tools and methodologies to ease up the assessment of risk, especially related to climate-related issues. And in this journey that we've been also partly showing to you, we have been also able to check different ways of working with impact chains. Silvia already showed, let's say, how impact chains are a strongly collaborative methodology, and that's why it doesn't really take much to do it, even maybe just a sheet of paper and a pencil, or let's say a board, or a couple of post-its, and that's definitely a very useful exercise because it gives you the time and the way to really get into the core of what are the components which are playing a role and are relevant and contribute most to climate risk or other types of risk. We've seen that even in the case of specific events, it's possible still to use impact chains as a way to conceptualize the complexity which is related with, for instance, multiple hazards which might be compounded or with multiple impacts that lead to different cascade risks. Now, the more we go into this direction and the more we want to approach, let's say, a variety of operational conditions, and the more, of course, we need for different types of tools to help us in this operation. So just to give you a quick overview of the different solutions that we've been exploring, we've been playing, for instance, for Kumu, which is an interactive let's say, platform for basically creating graphs. And as you have seen, topologically speaking, an impact chain really resembles a graph. And so, for instance, this is an example of an impact chain which has been set up and developed directly in Kumu. And the good thing about this tool is that let's say it allows us to build incrementally an impact chain, adding components, adding links, and not only building graphically the impact chain itself, but also, let's say, adding information to the specific elements of the impact chain. So, for instance, we can add narrative textual description to all the elements, but also to the connections, which are basically representing relationships between the different elements. And we see that many relationships, especially from, for instance, hazard to impacts and from impact to impacts, are also associated with causal type of relationships, but there are other types of relationships which indicate more generally, let's say, which exposed elements are affected by a single or multiple impacts, or what vulnerability, let's say, elements are affecting a specific impact or a specific risk. So this is a tool which allows us to be more systematic, and you see that it also allows us to basically grow up a little bit into the level of complexity that we can manage in this way. Next, also another tool, and we will also check out together with Silvia in a moment, we've been using is what is called a mirror board. Basically, it's just a virtual version of a board, and this has been particularly useful in the last years during the COVID time, where we had to conduct workshops with different types of experts and stakeholders, and you can stay with that. And the Kumu might have been a little bit more too sophisticated to say, so to say, but at the same time we needed platform to really discuss in a participative way, and this is something that Kumo is not, although it's possible, it's not the best option for. So for instance, what we did is to develop basic impact chains. This is an example of impact chain related with the climate risk assessment in Italy. So we did this, let's say, with a small set of experts, and then we placed the image of the impact chain developed with Kumo in a Miro board, and then we set up a workshop with a set of experts, and we just went over the different elements of impact chain, and we use just post-its as we would have done in a real in-presence meeting to collect, let's say, comments, observations. So we basically ran a discussion out of that, and all of this is collected in a Miro board and later can be assessed and can be used to update, for instance, the Kumu version of the impact chain. Another nice feature of the Miro board, for instance, is the fact that we can also attach different types of media, for instance, images, plots, piece of text, references to other websites or to literature items or documents that can basically enrich the discussion, make certain types of discussion, especially when it comes to the quantification of some of the elements of the impact chain more easy, and is basically increasing the reach of a tool as a collaborative, let's say, development solution. Of course, one point which is also important to be said is that the visual appearance of impact chains have basically quite an important role, especially when it comes to sharing the results of this assessment with others and specifically also with stakeholders or decision makers that could be a little bit I don't know, that can struggle a little bit with the complexity of a graph-like image. So one thing that, for instance, we've been using Miro for is also to synthesize a relatively complex impact chain on the, as for instance, the one on the left side in the screen into a bit more tidy description, which you can see on the right side, which is conveying maybe a smaller amount of information, but in a more easy and intuitive way to understand from stakeholders which are not experts in the field. Of course, one important point to highlight, and that's also why we've been increasingly going towards different types of platforms and solutions, is the fact that if we consider impact chain only a graphical exercise, then it can be just a slide in a PowerPoint or an image, but this is really somehow decreasing the amount of information that we can store and process. So in a parallel way, along with the other, let's say, type of solutions, we are also working on using a more structured, let's say, formats in order for the impact chains to be shared, reused, and also analyzed in a better way than could have been done only using with the graphical perspective. So although Excel is definitely not the best tool when it comes to intuitive understanding, and you can have a look at how an impact chain would look like when it's defined into an Excel, let's say, spreadsheet. On the other side, this provides already a very good solution to store this information in a library or portfolio, share this information with other experts, and start really thinking about impact chains as a way to really encode information and not just as collaborative brainstorming tool. By the way, Kumu, you can also move on, but by the way, Kumu is also allowing exporting and importing, let's say, graph-based representation with Excel format. So this is already a good, let's say, point. We are also further, let's say, advancing the discussion, and maybe in the next slides we will go more into details about that once more. Yes, and so we saw, and I just said that Kumu was, for instance, one good way to start dealing with little bit more complex impact chains. But what happens is that as soon as you try to capture, the reality of the different, let's say, processes which are playing a role in a single event or in a climate change, you will see that it's relatively easy to move from a simple impact chain as the one on the left side to a much more complicated one as shown on the right side. The more the experts are working with it, and the more it's really clear that the representation of the different relationships and the processes and the factors which are playing a role in risk is blowing up basically, and these are creating representations which are increasingly complex. And not only we have a problem visualization, because as you've seen in the preceding slide, this type of visualization exceeds, so to say, the capacity even of a Kumu like tool, and it also makes it more complicated for users and experts and even stakeholders to interact with this representation. But on the other side, this has to be taken into account very carefully, because I think one of the very useful features of impact chains is the possibility of conveying information only on the most relevant factors. And therefore, it's really important that if you will ever work with this tool or this methodology, always keep in mind the fact that it's really important to operate as soon as possible as a proper selection and the synthesis of the different factors which are relevant, both in terms of impacts of vulnerability or hazard, let's say, from these perspectives, in order to obtain more significant representation. But of course, we wanted also to embrace, to be able at least to embrace the complexity which is arising from a consistent and comprehensive, to say, analysis of a climate risk or a specific event. And one thing that I would just like to mention to you is the fact that what we see is that the impact chains can also be increasingly seen as a, let's say, as a way to conceptualize, encode, and structure knowledge in a different way, as we just showed to you in the other slides. And one way to see impact chains as a knowledge engineering tool, we are saying, is to couple this approach with what is called a taxonomy or an ontology. And I will maybe not go too much in details about that, but we can, in a simplified way, say that taxonomies can be seen as standard ways to categorize things, simple as that, and ontologies are basically an extension of a taxonomy, where not only we categorize things, so to say, or concepts, but we also categorize and explicitly describe relationships which can be occurring, which can materialize between the different concepts addressed by the taxonomy. And by using this additional perspective and these additional tools, which are ontologies and taxonomies, we can encode information and knowledge that are both conveyed by an impact chain through a structured so-called semantic representation. And we are currently, this is really ongoing work, and this is an interesting piece of research which is focusing on how to turn impact chains into semantic impact chains and exploit these features in order to basically unleash further the potential of impact chain as a knowledge engineering tool. And not only this semantic perspective impact chains can allow better interactive exploration of different factors, but can also turn impact chains into a form of advanced database or semantic database that could also be queried. And this is really paving the way to much more sophisticated systems. One of these systems is is being developed within a project. It's called CRISP, together with the German, so the GIZ, which is a German, let's say, body which is tasked with international cooperation, and in the specific context of agricultural impacts of climate change. And you see now something which is relatively complex. What you see, it is an impact chain itself and is representing climate risk for a specific type of farming system. And you see that this representation is quite complex, but what is nice is that this representation is based not just on an impact chain which was drawn collaboratively in a workshop, but on a database that was developed by experts in this field. And this is basically just shown as an impact chain, but it contains much more information. And all of this information is present into a backend database, can be queried on the fly, and the impact chain is generated on the fly directly by the system. And the user can, as Silvia is showing, interactively explore this information, this impact chain, get information on the specific links, add information, and later on also turn this information, next slide, into maybe a table or even a PDF report, and we can add, for instance, references to specific elements of impact chains. And just to let you understand that a tool which is very simple in the idea is growing in complexity, but also in capacities, and is also involving more and more expertise and skills. But at the same time, is also basically opening up for research on how, let's say, knowledge is or can be managed and can be used, especially to better understand the impacts of climate or the risk which is associated with very complex multi-other multi-risk events. Yeah, maybe I let you, Silvia, to draw a summary out of that, and then we can go back to the exercise.
Yeah, thank you, Max. So now we have just one last slide to summarize all the, let's say, main points regarding the impact chains approach. So not only for us in EURAC, but also within the PARATUS project and future applications of the impact chains as well. So we can say that the impact chains can be seen as a natural solution for risk assessment or for application-oriented risk conceptualization. So they are a powerful tool on the one hand to gather, to collect, to elicit knowledge from experts, but also to integrate knowledge from different sources. So the experts can provide just some concept, and then some more quantitative data can be looked for us, for example, in the Podraska case. And it can accommodate quantitative and qualitative components as well. So ranging from the indicator-based approach, but also to a mixed method approach, so where some components are described or some connections even are described quantitatively, or some are only described qualitatively through, for example, description that Max showed in Kumu, and it can capture the complexity of the chain of impacts, even, for example, using the query system or the visualization systems through Mirror, to the different visualization systems that we saw before. And it also can help to emphasize the role of vulnerability that is sometimes overlooked or not looked into depth as much as the hazard or the exposure components of risk. And it can also foster standardization, as if you develop more impact chains using a similar approach, a standardized approach, or similar tool, it's also possible to speak the same languages and also to share the impact chains among different experts, for example, using Excel, as Max showed before. And within PARATUS, but in general, as a next step, or where we are trying to put more attention now as within the project or in general, is that impact chains can be extended to capture really event-based risks, so to look at really specific past events. And also the impact chain approach can be integrated with the forensic analysis framework, so one can support the other. So the questions or the different points that build up the forensic analysis can really go and build event-specific impact chains. And also it can support the quantitative risk analysis, as some of the examples before proved, but also going more in depth, showing, for example, the relationship between the connections and the different boxes, so providing also quantitative data to support the qualitative or more conceptual visualization of the impact chain. So before moving on to the practical exercise, if we have time, does anyone have any questions?